Hi, I'm Mudinda and I'm here to help you understand maths better for free. Today we're looking at this calculus past exam question. I want you to go ahead and pause the video and give it a try and then compare what you have with what we have. Let's get right into it. In question 2.1, the question says write down the coordinates of the y-intercept of f. Now, we know that the y-intercept can be found by making x 0. Now, if x was 0 in all these three terms there, you'd end up with a 0 everywhere there, leaving you with just 30. And so we know that for 2.1, the y-intercept has the coordinates 0s to 30. Question 2.2 says, show that x is equal to 2 is one of the roots. We know that f of x is equal to x cubed minus 4x squared minus 11x plus 30. If you replace x with a number and it so happens to give you 0, then it means that that number is one of the roots, right? We've learned a little bit about this in the factor and remainder theorem. So let's go ahead and plug in an x value of 2. If you put this in your calculator, you would get that the x value of 2 makes y 0. Therefore, x is equal to 2 is a root. It's one of the roots of f. All right, let's have a look at 2.3. 2.3 says to us, hence, factorize f fully. So we know that f of x is equal to x cubed minus 4x squared minus 11x plus 30, right? But we now also know that 2 is a root, meaning that x minus 2 is one of the factors. Okay, we've looked at how to do this in a video that we've put out on factorizing cubic polynomials. But we're going to open a bigger bracket here, and in here we'll put a trinomial, right? So there's going to be 3 terms here. For the very first term, we know that I'll obviously have to put x squared, so that x times x squared will bring back my x cubed if I were to simplify this. Remember, factorization and simplification are opposites, so however it is that we will factorize this, if we were to simplify it, should bring that back. Okay, and so for that reason, I'm actually going to put minus 15 here at the end, so that negative 2 times negative 15 would give me the positive 30 there at the end. Now we now need to put an x term somewhere here in the middle. And we spoke about how to always get it right. We said, remember that the end goal is to focus in on this negative 4x squared. And we know from our brackets here that it'll come from 2 things. Firstly, when minus 2 multiplies x squared, we'll get minus 2x squared. Then when x multiplies whatever x term we have there, we'll get another x squared term, and together we want these to add up to give us the x squared term that we have of minus 4x squared. Okay, now what should you add to minus 2 to get minus 4? I hope you'll agree with me that you should add negative 2. So you should have negative 2x squared, meaning that the middle term there should be minus 2x. So that when x multiplies minus 2x, I'd get minus 2x squared. When minus 2 multiplies multiplies x squared, I'll get minus 2x squared. But we now know, matriculants, that we can complete this by factorizing this trinomial that we have here. I'm going to put x here, x there. Now we want factors of 15. That'll give us minus 2. That'll be 5 times 3 is 15. You make the 5 negative and the 3 positive, and you'll get the middle term back. Okay, so we've fully factorized, and we can see now that if we want to find the roots, we'd make y 0 here. So 0 is equal to x minus 2 times x minus 5 times x plus 3. Meaning x minus 2 is equal to 0, x minus 3 is equal to 0, x plus 3 is equal to 0, or x minus 5 is equal to 0. And so the roots are x is equal to 3, x is equal to minus 3, or x is equal to 5. Okay. Oh, sorry, not 3, but 2 here. So the two missing roots that we needed were minus 3 and 5. And so that's how we would get our answers there, 2.3, the other two roots. Great. Now matriculants 2.4 says the following to us. The turning points of f are A and B. They give us the coordinates of A, but they don't give us the coordinates of B. You can go ahead and pause the video and give it a try, but what we spoke about regarding turning points or stationary points is that at the stationary point, the first derivative of the gradient is 0. Now, f of x is equal to x cubed minus 4x squared minus 11x plus 30. So we're going to find the gradient f prime of x, which should be 3x squared minus 8x minus 11. We will then equate the gradient to 0 because it is only at the turning points or the stationary points that the gradient of the graph is 0. Now, in order for us to solve for x here, we can factorize this side. We're going to put here 3x and x. We'll put 11 here and 1 there. We'll have a minus here and a plus there. Now this then tells us that therefore 3x minus 1 is equal to 0 or x plus 1 is equal to 0. 3x is equal to 1 or x plus 1 is equal to 0. And so therefore x can either be, not minus 1 but minus 11, right? X will be 11 over 3 or x will be negative 1. These are the two x values that we found from making the gradient equal to 0. In other words, these are the two x values of the stationary points or the turning points, because it is only at the turning points where the gradient of the graph would be 0. Great. Now, the question here had given us the coordinates of A, one of the turning points, but we need to find the coordinates of B. Now, this 3 and 2/3 is the same as 11 over 3. Okay, that's just a mixed fraction, while this is an improper fraction. Same thing. So we know that B's x value is the other one, okay, because this is the x value of A. How can we find B's y value? Simply find the y value when x is minus 1. So minus 1 cubed, minus 4 into minus 1 squared, minus 11 into minus 1, plus 30. I'm going to go ahead and put this in my calculator quickly. Negative 1 cubed minus 4 into negative 1 squared minus 11 into negative 1 and plus 30. Now this is giving me 36, meaning that the coordinates of B are minus 1 and 36. Now the question then says in 2.5, sketch the graph of f, labeling all the important points and the intercepts with the axes. Alright, so I'll just draw quickly a Cartesian plane here. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now, the x-intercepts we found to be at 2, at minus 3, and at 5. 2, minus 3, as well as at 5. Those are the x-intercepts. And we found the y-intercept to be at 30. I'm just going to go ahead and do this. And I'll say somehow here we get to 30. There's a y-intercept there. We also found the turning points. First one was this one. Okay, now let's just write those out as decimals. 11 over 3, that's about 3.67. Then that, negative 14 and 22 over 27. In decimal, that's about negative 14.81. Okay, so 3.67, negative 14. Somewhere 3.67 and negative 14, that would be a turning point somewhere down here. Okay, at negative 14.81. And we also have a turning point, we said, at minus 1 and 36. Okay, so at minus 1 and 36, probably somewhere up there. Okay, so if we were to join all of these together, here's a turning point here. Okay, and here's another turning point there. Okay, if we joined all of these together, then the graph would look something like that. And you need to also show us the coordinates here. -3 is to 0, 2 is to 0, 5 is to 0, -3, 6, 7, and no, +3, 6, 7, and -14, 81. This one is 0 is to 30, and this one is -1 and 36. So that's how. All right, now I want us to think about 2.6. A lot of learners find a question like this to be quite challenging, but I'm going to try to make it a bit clear for you guys. So write down the values of k for which f of x is equal to k has only one root. I always just say move the k to the other side first for a question like this. So you have f of x minus k is equal to 0, and start to think about k as a number that we are subtracting from f of x. Now, whenever you subtract something or add something to f of x, you shift it vertically. Okay, so this is going to shift this graph k units down. Okay, or if k is a negative number, then we're going to end up with minus a negative number, which is just plus. So that's actually going to shift it k units up. K units up. Okay. Now let's think about the one root part. We want to find which scenario would make our function have one root. Currently, our function has 3 roots. It has a root here, and a root there. Think about what would happen if we shifted this graph 36 units down. Okay, we know that its highest point has a y value of 36. So if we shifted this graph 36 units down, that 36 point would come down here. The graph would look something like this. Will you agree with me that the graph would now have only 1, 2 roots? Okay, but if we had moved it just a bit more than 36 units down, then that turning point would be here, and the graph would look something like this, and it would only be left with this root over there. It would have only one root. So matriculants, I hope you agree with me that if we move this graph more than 36 units down, this displaces this turning point to now be under the x-axis, and the graph to now only have one root. So one of our solutions is, well, we could shift this graph more than 36 units down. So if k was bigger than 36, we would have f of x minus something like 37. Again, that would definitely make us have a situation where we have only one root. So that's another way to think about it, that k could be a number that is bigger than 36. Because if k is bigger than 36, this shifts the graph so low that this turning point will now be somewhere down here under the x-intercept, displacing these two and then leaving us with just one root. On the other hand, matriculants, what if you moved this turning point so much up that it now starts here? Well, then our graph will look something like this, with only one root over there. So that's another option. That's another option on how we can shift this graph to the point where it only has one root. But the y value there is 14,81. So we actually want this k to be something like 15, or actually negative 15, so that we have f of x minus negative 15, making us have f of x plus 15, meaning this graph is shifted 15 units up, and it's going to be somewhere here, right? Because that's 14, so it's actually going to be now displaced so much so that we would only have that one root left. These two would be lifted up. Okay, so we want f of x to be less than negative 15. We want it to be less than negative 15. Okay, we want k to be less than negative 15. No, negative 14,81, I mean. Okay, because then it'll be something like negative 15, making us have f of x plus 15, which would mean moving this graph 15 units up, and that would as well leave us with having only one root, not two. Okay, so k is bigger than 36 or k is less than negative 14,81. So that's how you answer a question like this, right? To make sure that this has one root, you'd shift this all the way down, so much so that only this root remains, or you'd shift this all the way up, so much so that only this. Now, question 2.7 is asking us about when the graph will be concave up. Now, we know that it's very important for us then to find the point of inflection. Okay, we've looked at the point of inflection in a video that we have on sketching cubic graphs. So if you haven't given that a watch and you don't know how to find a point of inflection, make sure you give it a watch. But we said we would derive twice. F prime of x would be 3x squared minus 8x minus 11, and f double prime of x would be 6x minus 8. We would equate the second derivative to 0 because it is only at the point of inflection that the second derivative is 0. Dividing by 2 on both sides here leaves me with, by 6 on both sides there, leaves me with x is equal to 8 over 6, which is 4 over 3. So this is the x value of the point of inflection. The point of inflection would be somewhere here. It's where the graph would stop being concave down and start being concave up. And the question is asking us, what are the values of x for which the graph is concave up? Well, it's concave up on this half here, which is everything to the right of the point of inflection. And we've just found that the point of inflection has an x value of 4 over 3. And so all x values bigger than 4 over 3 is where we find the graph being concave up. Awesome. See you in the next video where we'll be looking at question 3, and it's actually going to be on